All right, welcome. Every single useful program you use, whether it's your phone's OS or just a simple game, has to make choices. Today, we're going to pull back the curtain on how they do it by exploring one of Python's most powerful and fundamental tools.
Okay, so here's our roadmap. We're going to start with why programs need to make decisions in the first place. Then we'll get into Python's simple yes or no system. We'll see how Python can find the truth in some pretty surprising places, build our first decision with an if statement, and then we'll wrap up with what is maybe the single most important formatting rule in the entire language.
All right, first up, why does any of this even matter? Why is making decisions so crucial for code?
Think about it like a recipe. A recipe just lists steps, right? But it's kind of dumb. It can't tell you to use less sugar just because your bananas are already super ripe. A simple program is exactly the same. It just plows through instructions one by one. But what happens when things change and it needs to react?
And that right there, that's the big difference between a simple script and a really smart application. We need our code to ask questions like, is the user logged in? Or is this number I'm looking at positive? And then, this is the most important part, act on the answer. That is the power we are unlocking today.
Okay, so how do we actually give our code this awesome power? Well, it all comes down to this really simple, super elegant tool that Python has for answering any yes or no question. And here it is, the Boolean. The best way to think about it is like a light switch. It's either on or it's off. There's no dimmer, no in between. And in programming, that's just true or false. Literally every single decision your code makes boils down to one of those two answers. So you might be wondering, where do these true and false values even come from? Well, a lot of the time, they're the direct result of a comparison. Like when you ask Python, hey, is 7 bigger than 5? It doesn't just nod its head. It actually gives you back the Boolean value true.
And here's a really cool little secret, kind of a behind-the-scenes look. Under the hood, Python actually treats true as the number 1 and false as the number 0. It sounds simple, but this idea is a cornerstone for all kinds of clever programming tricks.
Okay, so let's keep building on that idea, because Python's whole concept of true and false goes way beyond just those two little words. It can actually look at pretty much any value and get a vibe for whether it's truthy or falsy.
Yeah, that concept is called truthiness, and you can think of it as Python's built-in gut feeling. Almost everything you can make in Python, numbers, text, you name it, is considered truthy. But there's this small, very specific list of things that are considered falsy.
And if you look at this list, you'll see a really simple but super powerful pattern start to emerge. Basically, in Python, emptiness is almost always considered false. The number 0, an empty piece of text, an empty list, even this special value called none, which literally just means nothing, all of these will act just like false when you're checking a condition.
Okay, so keeping that rule about emptiness in mind, let's do a quick quiz. What do you think happens here? We're asking for the Boolean value of the string of text that says false. Go ahead and pause for a sec if you want to think it over.
All right, you ready? The answer is A, true. It's a classic trick question, right? Python doesn't actually care what the word means. It just asks, is this string empty? And since the string false has 5 whole characters in it, it's not empty. And if it's not empty, it's truthy.
Okay, so now we've got our true and false values. We know how to get them from comparisons and from this whole truthiness idea. So now, finally, we can look at the actual structure that uses them to make a choice, the if statement. The if statement is basically your program's bouncer. It stands at the door and decides who gets in. And it's built with just 4 simple parts. You start with the word if, then you give it a condition. That's anything that ends up being true or false. You finish that line with a colon, and then, and this is absolutely crucial, you indent the code that you want to run only if the condition is true. Let's check out a super simple example. The code is asking a question. Is the value in this temperature variable greater than 30? If the answer is yes, if it's true, then it runs that indented line and prints it's hot. But if the answer is no, false, it just skips it, completely ignores that indented part and moves on.
Okay, now that little bit of space in front of the print command, that wasn't just to make it look nice and neat. In Python, that spacing is a non-negotiable, super important rule that literally defines how your code is structured.
This is probably one of the most unique things about Python. A lot of other languages use like curly braces or other symbols to group code together. But Python?
Python uses white space. That empty space at the start of a line is what tells the program, hey, this line of code belongs to that if statement right above it. So what are the rules? Well, the standard is pretty simple. Just use 4 spaces for each level you invent. But honestly, the most important thing is just to be consistent. If you follow these rules, you will save yourself from one of the most common headaches that new Python programmers run into. Trust me.
And here's what that looks like in the real world. On the left, everything's perfect. The print statement is indented, so Python knows it's part of the if block. That code works. But on the right, that missing indentation completely breaks the structure. Python has no clue what to do with that print statement, and your program will just crash with an indentation error.
So let's just do a quick wrap-up. We've talked about why decisions are so important. We met Booleans, our true and false tools, and we learned how to use if statements and, crucially, proper indentation to put it all together. This is a huge, foundational concept in programming, and now it's something you know. It's yours to keep.
So that leaves you with a question. Now that you know how programs decide what to do, what's the first decision you're going to teach your code to make? Maybe it's checking the weather to see if you need an umbrella, or if a password is long enough. Whatever it is, the power to build that logic is now in your hands. Thanks so much for joining this explainer.